Hi all, welcome back to the channel. To continue with that interview preparations, let's see some good topic today. So let us go inside. We are working on AP, so we'll put some topic in AP itself. So today we will last session we have seen resilience, which is an key area where most of the questions, and you can expect definitely some questions in that area. If there is any communication failures, how we need to react. So if you missed that video, please go and kindly check that video, resiliency. So today we will cover rate limiting. Okay, so what is rate limiting? In general, if you are working within intranet applications, we usually don't worry about that request or count or something like that. But the user facing applications, rate limiting is one of the key factor. So if in a particular interview and the people are hiring you for any application which is an user facing application, then definitely you might expect some questions in rate limiting. Because from my experience, I missed this topic because I worked on many intranet applications. But yeah, this is a good one, so don't miss this one, have some idea. I also worked on some user facing applications like live streaming applications and many educational applications where users might be coming and they might be eating. One of the good example and a good story I can remember is one of the gateway application where we found some issues. A person created a bot and he was keep on eating our server, and he is facing our resources, and we face lots of issues. So at the time I understood the real importance of rate limiting, and we need to secure the traffic, right? All the traffic whenever we are giving it to public, it is not always safe, right? We need to be very careful, and we need to do the regular analysis how the traffic is, and all are you valid user or not. Because people are playing with things, and they are not how to say, they are not very serious about the items, the struggles what developers and the industry is facing. Okay, so quickly jump into the topic. Yeah, the quick summary is it's a control how many requests a client can make within a time window. It, as I already informed, protects services from abuse, ensure fair usage, prevent system overload. This is one of the key point, because people might be creating the issues by overloading the systems, where the real actual users might be facing the exceptions. Due to this bots and other things, our system might be replying back to the bots, and the real users might be facing the exception, or they might be facing some slowness. Both are dangerous to us, because people, and once people got frustrated, they won't come back to our applications. Okay, so we need to make sure, and we need to do the rate limiting. We need to always do a monitoring on the traffic. Okay, yeah, let's get started. A nightclub allows, it's a good example. It's only allows 50 people to enter per hour. Once 50 people are full, then the new arrivals need to wait for their chance. This protects a cloud from overcrowding. Okay, this is a general example. You can keep this in mind. Okay, why do we need to do that rate limiting? As I said, DDoS attacks will be there, and for fair usage, protect downstream systems, because it might cascade the failures rate. A request is not going to end up in that gateway itself. It is going to travel across multiple services. A unwanted request flowing into our entire applications, then it is a mess, right? Hope you understand. Next one is controlling the cost, because everything is cost here. Nothing comes for free. So your resource has been used in this way, it is going to be a waste of cost for that particular industry, right? Next, then maintain and the service quality. Service quality, as I said, people might get frustrated. There might be some slowness. They might be ended up with closing the sessions. That lots of issues might be raising. To overcome those issues, we need to do the rate limiting. Okay, so now you got some idea, right? What is rate limiting and why we need to do that. So let's jump into some algorithms. How in our real world we are doing this rate limiting. Okay, the first example is token bucket. This is a generally used one. where it is a simple to implement, and it is very easy and most widely used. Tokens are added to your bucket at fixed rate. Each request consumes one token. If no tokens are there, then requests are rejected. Hope these two lines clarifies everything, right? So let's quickly see an flow diagram. Okay, tokens added steady. 10 tokens has been added to the bucket. Okay, each request comes in will consume one token. If token is there, it will process. If token is not there, we will send out 429. Okay, when we are working on this, when we are studying or we are learning this rate limiting, you need to be aware about this response code 429. Okay, and here we use the jargon burst. Burst is one of the item. Burst is nothing but if more than the capacity, then 50 requests can come instantly also. Okay, so once a 50 request comes, then our application will burst and it will stop serving the further request. Okay, that threshold rate, the threshold is what we call it as burst here, burst capability. We need to benchmark it and we need to make sure that based on we need to do the analysis on our regular traffic and we need to set up this limiter. Okay, when speaking about this token bucket, then we need to understand the parameters, the refill rate, bucket capacity, and cost per request. As I said, tokens added is the refill rate, and the maximum tokens in a bucket is called bucket capacity, tokens consumed per request. So one token per AP. So these are the items you need to remember because when you are working with the token bucket, these are the parameters you need to take care and you need to benchmark it. Okay. Here is a simple code implementation. I will share this particular site as an PDF. I'll try to add it to the description. It will be helpful for you guys. Okay. And some pros and cons allows for simple to implement, memory efficient, predictable. Okay. Here we need to do that two params, right? Adding the tokens and you need to fine tune the bucket also. It might look easy, but in real world I too face lots of issues on fine tuning it. Okay, then the bust can overwhelm if too large, and clock synchronization issues in distributed setup. Distributed setup, it is a headache, definitely. Token bucket we should not go or we should avoid. And yeah, by now we will complete that token bucket. I will come up with lots of examples, real world examples and technical examples down the line once I completed and give an overview about all the algorithms. Yeah, let's jump into next one. It's a fixed window counter. Time is divided into fixed windows. Each window has a counter that resets at the end of the window. Say for example, every 1 minute. Every 1 minute we'll be adding some, say for example, 25 requests is there. If you can see here, right, counter it is 25 requests and 5 requests is remaining. So it can serve additional 5. And this is 30 requests and 0 is remaining. So like this, a burst at 10:59 and 150 requests in 2 seconds will pass. So how to say, we might be having benchmark as 50, but at the end of the timing, it might be overload, right? Let me show you some other good examples so that you can understand. Yeah, if a client sends 100 requests at 10:59, this 59, right? And another 100 at 10:1, both windows allow them. Even though 200 requests happen in 1 milliseconds, you got the issue right. Within 1 milliseconds, at the end of the first time boundary and the start of the time boundary, both is allowed lots of requests. So 100 and 100, 200 has came. But our benchmark and our service can able to handle only 100 requests. But due to that sliding window, we are closing at a minute and then opening the another minute, right? This will cause these kinds of issues, the boundary issues at the time close and at the start of the time. If both lots of requests comes at the end and lots of requests comes at the start of the request, it will create an issue. Okay, so to overcome these issues we are using sliding window, the next algorithm. Okay, now it's simple to implement, memory efficient, works well for most use cases. 2x traffics, as I said, when you are speaking with this one, it's always about traffic at boundaries. It might look simple, but in real world, this might happen. During our testing phase, we can't able to find it, but in real production scenario, we might face that the boundary issues. That's why here we are keep on highlighting that as a con. Okay, let's jump into next one, sliding window. It is simple. Instead of checking every 1 minute, we are allowing 60, right? Instead of doing it in that way, we'll pick the last 60 minutes. Okay, say for example, now the time is 10:27 means we will see for last 15 minutes or last 30 minutes. Okay, so from 9:57 we will check how many tokens has been, how many peoples has been there, and with that we will move that token request, adding the token request. Okay, so shows timestamp of all the requests and slides the window continuously rather than resetting at the fixed boundaries. Okay, instead of counting per hour, you look at last 60 minutes from now continuously. The window moves with the time, not in the fixed jumps. At end of every 1 hour, instead of adding and adding some more tokens, what we'll do is we will check for last 1 hour. Say for example, our benchmark, a particular service B can able to serve around 50 requests means, then last 60 minutes it will allow only 50 requests. Okay, instead of jumping on that fixed windows 10 o'clock to 11 o'clock, 50 11 to 12:50, in that scenarios we might miss the boundaries and we might end up with under request as well. To overcome these issues, we instead of checking and we instead of cutting over at that 1 hour window, what we are doing is we are doing that sliding window. Instead of checking 1 hour once, we are just checking last 60 minutes. By this way we are avoiding that boundary issues. Okay, quickly, this is code implementation. I will add it at the end. Sliding window with counter, it is a hybrid model combining both fixer and this one. This is nothing but adding a counter as well. This is little complex. Most of the cases people are not using it, but based on the case to case, if your use cases is required, you can pick this option as well. Okay, leaky bucket, it is an interesting and one of the good algorithm. In some scenarios it is very handy and it is useful. If the bucket is full, requests are discarded. Got it right? Yeah, water tank with a small hole at the bottom. Water enters at any rate but leaves at constant rate. It might flow like anything, but it will come out in a constant speed. If the flow is more, then that water will be wasted. Same way, leaky bucket is nothing but the request will be flowing in and it will be going in a steady rate. If it is overflow, then we will prevent that overflow. Okay, hope you understand. Then let's move into other items. Smooth outburst, predictable output rate, good for network traffic shaping. No burst capability, can waste capacity if not fully used. Less flexible. Okay, say for example, in some scenarios like if you are opening a movie ticket at night 12, you might expect lots of traffic, right? So in this kind of situations, you can go with a leaky bucket where the request will be flowing in and it will be processed in a fair manner, and the additional requests will be rejected so that users will be going and retrying it, or else we can make it as a queue and we can streamline the process. So combining these algorithms, you can rate limit the incoming traffic. Okay, so let's move into some of the comparison. Token bucket, yes, burst is allowed, others it's not allowed. Burst is nothing but that 50, more than 50 it is not allowed. Memory usage, it is very low. Fixed window, it is very very low, but sliding window it is high, because we need to keep in mind and metrics that lots of requests, everything we need to save, and based on that we need to make the decision. So the memory usage is high over here and others are low. Accuracy, it is good. It is an standard, industry standard. Mostly people will be working on token bucket. And poor at boundaries, and it is an excellent choice for sliding window for complex systems. And if there are more requests per seconds, then people can carefully choose this and they can implement it with some benchmarks. Okay, this is a very good and good. Complexity, it is medium. It is very very simple. Every 1 minute once adding it and removing, it's very simple. Sliding window, it might look easier when we are reading 60 minutes last 60 minutes request, but in reality requests might be coming in and going out, so implementing it, it's a challenge for us. Okay, that's why complexity is high. Both others two got medium. Okay, so these are best for, let me come to real world use cases. Public API, they got a token bucket, 5000 requests per hour, allows, but simple to explain to the developers. Okay, got it right. For these kinds of items, they are using these kinds of algorithm. Login attempts, fixed window, 5 attempts only. Because 1 hour you can, sorry, for next 10 minutes you can be allowed only 5 times. Simple boundary burst is acceptable. Okay. Next one is service mesh, API gateway, internal communications, lots of things, lots of flows are happening between the services. Then sliding window is a good one, where 1000 requests per second is allowed, and memory efficient, accurate enough, and it is good for a good candidate for choosing between the service communications. Especially as they said, service mesh is a good example. Okay. Next one is network traffic shaping, leaky bucket. Network traffic is like how to say, sudden spike in the traffic. Those items and all, it will be helpful. So leaky bucket is one of the good item. For circuit breakers, sliding window is a good thing where we can have 50% failure rate, accurate failure detections. Okay. Apart from that, we got cooling servers there. If there is a sudden spike, how it can be handled, like that. Lots of items over this area. But for interview perspective, hope this is enough for us. So quickly you go through the algorithms, and then it might be helpful for your real use case also. Whenever you are implementing or working on any new service developments, these algorithms will be helpful. Okay. Yeah, thanks. And comment for more topics so that I will check and I will get back to you with those items. Slowly, I'm planning to go with API items one by one. And finally, we'll move to microservices as well. Okay. Yeah. Thanks. Thanks all. Thanks for your time.